October is a spooky season, a time of year for critters, ghosts, and skeletons to crawl out of their tombs. Not just because it's Halloween, but October also happens to be International Fossil Month, with several astounding fossil discoveries not only celebrated, but published and unveiled to the world. Welcome to the annual PaleoRewind, with October segments being covered by yours truly. So without further ado, let's dive into October's discoveries. New face for an old bug. Arthropleura is one of the oldest and most infamous arthropods ever discovered, and by far one of the largest. A truly enormous insect. It's in the running for the largest arthropod to ever walk the earth, just short of the most enormous of ancient sea scorpions that once swam Earth's seas and swamps. Thanks to its large size, Arthropleura has risen to infamy, being featured in several documentaries displaying its great size. Yet, despite being amongst the most popular of fossil bugs, there has been quite a big debate on what this ancient insect would have looked like, especially the head, with fossils preserving Arthropleura leading to discussion on which end or segment represents the head of the animal. In October of 2024, the debate seems to have finally been settled with the astounding discovery of two Arthropleura fossils, both preserving the heads of these fossil bugs, with CT scans revealing for the first time in such exquisite detail the true faces of Arthropleura, detailing internal sets of mandibles, two pairs of external maxillae, and even its eyes, which for the first time have been revealed to have sat on stalks, giving them a greater field of vision. This analysis has also found that based on these anatomical characteristics, Arthropleura's place on the Myriapod, or centipede and millipede family tree, suggests it's a placement just outside of Diplopoda, the group containing the modern lineage of millipedes, as a sort of stem millipede. Two birds and one stone, or more appropriately, two mysteries and one bug. A new bull on the block. South America has been home to a wide array of predators throughout its natural history, including its share of meat-eating bulls, from the notorious Carnotaurus to the lesser-known but positively gigantic Carcharodontosaur called Taurovenator, a creature that, unlike Carnotaurus, didn't derive its name from any horns, but instead the ranch it was recovered from. In fact, for the longest time, there wasn't much to go on for Taurovenator other than a few fragmentary skull bones. That is, until October 2024. A study published in October revealed the discovery of a brand new specimen of Taurovenator, revealing exciting new details on this ferocious carnivore. From this description, Taurovenator has been unveiled as a brand new member of the Giganotosaurines, the subfamily of giant South American Carcharodontosaurs, including Giganotosaurus, Mapusaurus, and Meraxes. Meraxes in particular having several close affinities to Taurovenator, suggesting a close family relationship between the two, sharing various characteristics with one another, such as the post-orbital bones projecting like horns over the eyes. Which is fitting, considering the names of both dinosaurs. Horns weren't the only distinctive feature Taurovenator shared with other Carcharodontosaurs. It also had interlocking vertebrae similar to Acrocanthosaurus, strengthening the neck along with tall vertebrae housing powerful muscles, allowing them to generate incredible bite forces when going on the attack. But Taurovenator's traits weren't just what other Carcharodontosaurs had. It had its own unique quirks and characteristics, including having the shortest arms of any Carcharodontosaurid. And yet, despite the reduction of these limbs, still maintained an impressive flexibility. Taurovenator stands as an impressive addition to a long line of impressive predators, even if its arms started to have a bit of a trade-off. A rhabdodont. Out of time, out of place. Rhabdodonts are a rare group of ornithopod dinosaurs, found in various isolated pockets of the world, from different sites in Europe to as far away as Australia. But for the first time in 2024, a discovery of a new genus of rhabdodont called Ameliosaura was found in an unexpected place, South America. It's a groundbreaking discovery, as ornithopods are rare in South America, rhabdodonts even rarer. In fact, Ameliosaura is the first rhabdodont found from the continent. Even more groundbreaking is the fact that this dinosaur hails from the Valhanian stage of the Cretaceous period, a time so early it's just a few million years after the end of the Jurassic, fresh off its heels, making it not only the first South American rhabdodont, but the oldest within the group, dating back to a whopping 138 million years ago. The discovery of Ameliosaura from this unique time and place provides key clues on the ecological shifts that occurred following the end of the Jurassic period, and the evolution of dinosaurs in the Cretaceous, more specifically, the evolution of the ornithopods, as they began to diversify during this time. Walking with beasts. Bones alone aren't the only things that solved mysteries this year, but the traits contained within them that tell the stories stretching across time, step by step. Literally in the case of a recent study that tracked the evolution of limbs and locomotion in the evolution of mammals. In October 2024, a study compared the varying postures and limbs of living and extinct animals to examine the evolution of limb structure and locomotion through the past countless millions of years, utilizing cutting-edge biomechanical models to simulate the muscular and skeletal structures of mammalian ancestors, in order to simulate their locomotive capabilities and forces that went into them. The culmination of these findings suggests the shifting postures and limb anatomy were not shaped by a linear or straightforward pathway, but a rather complex one, stretching across different lineages with various dips and divergences, shifting according to various events and environmental changes throughout natural history, such as the Permian mass extinction, with fossils of extinct synapsids pointing towards the likelihood that upright limbs evolved much later than previously hypothesized, evolving as a much more derived characteristic amongst later Therian mammals of the Cretaceous. The results are not only useful for paleontologists, but remarkably, other fields of science as well, with these very same comparisons not only leading to the understanding of evolution of mammalian limbs, but the data collected from the study and simulated limbs lend to the advancement of creating more advanced locomotion in robots, especially over various forms of terrain and environmental conditions, by analyzing how these limbs functioned. In other words, one small step for Dimetrodon, one giant leap for mammalkind. Thanks for joining us for this year's PaleoRewind, everyone. Be sure to check out the rest of PaleoRewind for coverage of the amazing discoveries of 2024. And of course, looking forward to the discoveries of 2025. Happy New Year, everyone!